guys. Seems something went wrong earlier and the stream accidentally started before it was ready. So I had to create a new one, so we're now at 103B. But let's see if this is all working, if we have audio. I think so. Hello. Maybe I should move it a little bit closer. There. Audio. And we have video, and let's see, we have the desk cam. I already prepared some testers. Noise. Can we revive the heart? I don't know why it's gone. Sometimes it's there, sometimes it's not. Oh wait, the heart is now part of the... Does it still do anything? No. It's now part of the chat thing. So let's down the music to something more manageable, right? Okay, let's move this out of the way a little bit. So, how is everyone's evening? Not on screen. No, I see it in my chat, but it seems to have not. It seems to be gone from the screen somehow. Don't know. Well, some people hated it, some people liked it. So I guess the haters win for this round. Let's see, because so I had to delete the prior stream, but I think Jacco was one of the first, or at least the first one to like it. And we of course now have Johnny Bergdahl. I don't have. Do I have a? I don't. Oh, maybe I can make the fire pink, Johnny. Let me check. This one. Well, I can't really see that on camera. Maybe this one. Yeah, maybe. This one? No. Well, we'll stick to this guy here. There. It's pinkish. I hope that's good enough. But let's see. Chris van der Heren is here. And then I said something. Nigel Young, Jeremy Holmes, Dutch Taurus, and he wants his lights to be turned purple by Johnny Bergdahl. I don't know, guys. Maybe you should do that in private. Made it for once. Glad I'm on vacation, so now I can catch it live, says Norman Douglas. Welcome. Hi, everyone. Gave up on my Halloween display. Taking it down twice was too much. Florida. Why did you have to take it down twice? Like in different years or this year? We'll try again for Christmas. Then we started the hard talk. Oh, well. Oh, Jeff Hammer is here. Do you have any 3D printers? Curious what you use. I used to have an Ender 3, which I tinkered with for years and years, and sometimes it printed something, but I think I spent more time messing with it than actually printing stuff. And then I bought a Bamboo Labs X1C with AMS, and that's been excellent, and I've been printing lots of things, and I've been tinkering none of it. So yeah, I have an X1C, and it's been great. Oh, hurricanes in Florida. Oh no. I guess the hurricanes would win from any Christmas or Halloween decorations, huh? What date is Halloween? Halloween. Yeah, 2024. Oh, it's 31st of October. Okay, well, then people still have a little bit of time to build their stuff. Oh, Luke Abel says, Bamboo Lab all the way. Love my P1S plus AMS. Yeah, well, I have the X1C. And the only thing I modified on it is that I have a little riser that has ventilation holes I can open or close, so I don't have to open the door. And it has a bright LED strip inside, controlled by an AN Penta Mini, actually, and Home Assistant. And that also works great. And then I have another riser on there for the plates, and yeah, but modified printer, no, nothing. It just prints. It's great. Wim Kramer says, hallo, goedenavond allemaal. And then Stefan Wiesenberg says, goedenavond. Jeremy Holmes, I know that feeling. I'd love to get a bamboo printer one day. Yeah, sure. They become projectiles. Nobody wants to get impaled by a witch on a broom. Oké. Stefan vraagt, Quindor, ga je nog een keer in Nederland voorraad houden? Maybe at some point. We are still working towards that. But certifications take long. They're expensive. So even if I do, which I do plan at some point, it will be a very limited assortment. So yeah, we'll have to see. Lowrider V4 DIY CNC just released, so I'm 3D printing 24/7 on my hacked Creality CR6 SE. Okay, don't know what that is, but sounds cool. James R says, hey Quindor, I'm the guy with the battery-powered LED stage you've recently assisted with on Discord. It's rocking. Cool. Awesome to hear it's working. Skylar donates $10. Do you anticipate an analog dimmer that supports the ESP32 Ethernet hat? Also, have you considered PUE integration into the Lumen Cache ecosystem? So the first one is no, or rather that already exists. There is the AN Penta DIY, and that supports the current ESP32 ESP32 hat. So the AE Plus or the Ethernet or the normal version, external antenna, etc. So that works on the AN Penta DIY, but that's DIY only. For the pre-assembled boards, those are going to be fully designed from the ground up and fully pre-assembled, basically. And do I have one here? Well, I don't know if I already showed this or not, but if so, if not, you're going to see a secret. And if so, well, so we're working on getting this one released. This is the, oh, I already showed this as the secret last time. So this should be the AN Penta Plus, but I was having a major headache day, so it's called the AN Deca Plus, but the plates are getting remade. But while we're at it, I can add the right screw terminals to this guy, because I now have the right screw terminals. So that was the first one. The second one, have you considered PUE integration into Lumen Cache ecosystem? So the Lumen Cache doesn't really support PUE. They use their own standard for stuff. And if I build something like that, I would do it slightly different. And I've given that a lot of thought. Hint, hint. So who knows what you might see in the future in that regard to something similar, right? Or something with the same purpose, but not similar. So yeah, well, who knows? Stefan Wiesenberg, thanks. I didn't think about certification. Just received a dig quad today. Awesome. Good to hear it. Good evening all. Did I already miss the smoke? No, we haven't started yet. It's 16 though, so we should start at some point. I'm showing the secret from last time, but now with pluggable terminals installed, because I hadn't tried those out yet. Just bought an AN Penta Mini. I love it. Nice to hear that, Jordy. There was a lot of passion that went into that project on these two, but they're finally getting released, or getting close to release at least. 50 people didn't hit like. I am disappointed. 2115, let's go. My Dig Octa couldn't connect it to WLED the other day. It was working, and then without changing anything, stopped working. Factory reset fixed it though. Strange. Yeah, that is strange. I have looked at the ESP32 WT32 ETH1, but it's basically a less sophisticated design. I don't know how to say that. Less feature-rich design as my own ESP32 ABE, which is basically just as expensive, except for shipping maybe. But yeah, on certain boards where I build Ethernet, like on this one, this is going to have Ethernet, analog dimmer and digital. Whoa. It's first hybrid board. I'd rather just build the Ethernet circuit as a whole instead of rely on a plug-in board. So yeah. Oh, this is the one with the cracked faceplate. Oh well, I'm getting new ones for those anyway. So, oh, Pepsi made it to the live. Awesome. Yeah, so now we have these beefy terminals for the input power, and then for the output we have 4 times positive, actually 5 times secretly. And then we have power injection output for very high power MOSFETs. And we have some tricks here with digital output together with analog output. And we've been working on WLED to support that correctly and things like that. Paolo CJ has been doing a lot of work in that. So that is great. Yeah, but these are coming soon, I hope. Yeah. There's always roadblocks. More roadblocks every time. But we're working on it. We're working on it. So, when we're here, today we're going to do some more testing on power supplies from Aliexpress. Because last time, of course, we checked a few out. But I have those in a box here. So let's take a look at this box. There should be some empty boxes. Yeah, empty boxes. So these are the ones we checked out before. Okay, this can go here. Empty box. So we checked out these three, I think. Right? So we had these various models, and they all kind of performed the same. They all sucked. But I didn't take proper notes. So I'll have to retest these off stream. But this box is still full. This box is still full. Let's put that back in here. And I'll put these on the have to test that later pile. Okay, we can go here. So we have these two boxes. Those are still full. But look at this. There is a package that isn't unpacked yet. There is this, which suspiciously looks like a power supply. And then I've got these three stacked together, which, why is my 60 FPS not 60 FPSing? Okay, it is. Okay. And so we have a lot more to go through, right? So we'll first unpack these and take a quick look. And then we'll start with the ones I already had, I think. We'll see. So we're doing a mini Quinbox. Where's my Quinbox knife? Here it is. To actually unpack some. So these go first. And then let's take a look at this one. Because I have the sneaking suspicion that these two are actually the same. No, none of these are Meanwell. Meanwells we know of, because we also tested those in the last live stream, that they actually perform like they should perform. So, if it says it's going to do 300 watts, it'll do 300 watts. No, it's not actually the same. Okay, so yeah, we have one more. Let's see if this is also a power supply, because I have to dig this out from my giant pile of packages. Oh, yeah, great. What's this? Is this a power supply? Linear lighting leader. Okay, well, it's 12 volt, 300 watts. That looks like a power supply, so it goes on the stack. Wow, this is tiny. It's 12 volts. Oh, it says 12 to 24 volts. So what is it? Oh, it says 12 volt? Okay. Oh, right. I bought these because I saw people buying them. I was like, oh, okay. Maybe those terminals are nice. I don't know. But, I mean... yeah, we'll see. We'll see. We'll test it out. I doubt this will do 300 watts, because that would mean 25 amps. This thing says it'll do 25 amps. I always wonder who they're fooling, if they believe this crap themselves. My monthly AliExpress budget. Well, it actually depends slightly on how much you guys buy. Because the more you buy, the more AliExpress budget I have using the affiliate links. So if you go out of your way to use the affiliate links, I get to buy more crap to test for you guys. So what's this? Oh, this. Oh, no. Okay. This is not a power supply. Okay. This is something, a different topic. So that goes back in the box. Oh, then maybe these aren't power supplies at all. Maybe I got the wrong stack. Did I look in this one? I don't know. I guess 50 amp RGB CW. That is also some kind of LED amplifier. Okay, so this one goes here. Oh, so we might have less to check out. Oh, okay. Well, still a 4. Let me check in this package what's in here. Yeah, so it depends on what kind of meanwell you have. Oh no, this is also a high-speed amplifier because I wanted to take a look at some of them. That also is not a power supply. I'm going to look in my box to see if I missed some packages. I'll be right back. And otherwise, we still have the 4, so we check out the 4. Whoa. Okay, those were all the power supplies we need to test. So that's good. That's fine. We have 4. I'm not even sure we're going to do 4. But I am going to keep notes. So I'm going to open that real quick over here. PSU live stream 2 notes. Okay. Oh, Gizmevo is here. Nice. Yeah, so some power supplies will use a lot of power when idle. Generally, the higher quality meanwells, like UHP series, will use half a watt to maybe a watt. But if you have lower series, it might use more, especially you have cheap-ass non-meanwell power supplies. Yeah, they can easily use 10 to 15 watts. That's why most of the dig boards have a functionality in there where you can run it from 2 power supply, like a 5 volt 2 amp phone charger, and then have your 5, 12 or 24 volt main power supply, which can get turned off when the LEDs are off. So that way you save a lot of idle current, right? We have our set of testers here. Let's turn those on. Because we have 2. Because if one actually manages to do 300 watts, well, then we need more power supply. Bossiatro brand any good? I have no clue. Kiwi Christmas. I'd have to look at it. So, well, let's start with the ones I already had. This one has this really cool holographic. Whoa! It's also the biggest box. So let's check that out. I didn't prepare my AC cable, so that's bad. Okay, so this is the BDX300-24. It says it can do 12.5 amps at 24 volts. Well, we'll see about that. I actually need to open the stream description because I need to find these power supplies and then link them, because I hadn't done that yet, because I didn't know which was which, basically. Let's see, power supply. No. So I'm just trying to identify it from the images. I think. Yeah, BDX blah blah blah. Okay, so copy link. Go into here. PSUs. 1. What is the brand? Niton. Safe. Okay. Sorry, I need to do a bit of note keeping here because otherwise I'm going to forget. Okay, I need a cord which has exposed stuffs. Should have had one here, but I do not. Oh, here it is. I used it for my. Oh, did anyone see the video on this guy? Oh, look. This guy here, the RSP 150 from Meanwell. That is a nice option if you don't want to use a relay, or you don't feel comfortable wiring in a relay or whatever, but you still want a relay. You can use this guy with two little wires attached to a Dig Octa, and basically the power supply itself has a relay built in which you can control with the Dig Octa. So that was awesome. Of course, it depends. These aren't cheap power supplies, so there's always that versus. I should have some news for that Kiwi Christmas in the future, but right now that's a no. Yeah, but those are nice power supplies, and especially if you want the relay function, it basically has it built in, so that's good. So let's see here. We have earth. Oh. Oh, we have a red one, so neutral's likely blue. I'm used to having. Oh, damn it. These are really tight. I'm used to having yellow, blue, brown, but I'm sure red is the brown one in this case. Well, these terminals are at least decent. That's good. So, okay. Then we hook up our testers, and this one is big enough so we have enough terminals, so that's nice. So we can hook up both testers with the anticipation that it will actually deliver 300 watts. Place your bets now. Should we make a poll from that? Let's make a poll. Let's see. Poll. Start poll. Will it do 300 watts? Yes, no. Start poll. So we have until I've hooked it up, and then we'll know the results. So let's see how pessimistic you guys are. Maybe one of these actually today will actually be good. Maybe. I mean, you never know. It could happen, right? I bought them to test them, so maybe it's like, oh, maybe this is a good one. Probably not. Okay. It can handle 500. Well, then I have to hook up another tester. Now, I can handle up to 100 amps or, let's see, about 900 watts. So that's no problem, but we'll have to do some more intrinsic wiring. This fork is kind of bent out of shape there. Oh, Mr. J's being positive. This top screen here, it feels loose. Can I take it off? No, can't really. I don't know. It feels decent enough quality. I mean, it has a nice PCB inside. There's a plastic protecting the metal on the bottom. That's good. If any of the PSUs we're going to test today has a chance, I'm going to say it's this one. but we'll see. We'll see, right? So, testers. Oh, wait. Everything's getting stuck. There. That's good. Okay, I'm going to end the poll. End poll. Let's see what we got. 300 watts, 67% says no, and 32% says yes. Does it have to work afterwards? I don't know. I am going to take my safety glasses provided by Draadstaal, because you never know. And I'd like to keep my eyes. You're right in time there. We're going to turn the first one on now. So, let's turn on the power. Okay. Ooh, it has a red light. Fancy. And we're measuring 24 volts and 24 volts. Good. So all connections are in order. And the idle current, I guess we should note that. Idle current is 1.75 watts. Okay. Cool. So let's go for... how is this working in? No. Let's go for 1 amp. 1 amp, no problem. 2 amps. Okay, we're at 50 watts. That's not bad. 3 amps, 72 watts, and we're drawing 80 watts. That's pretty good, actually. That's fine. Still 24 volts. There we go. 4 amps. Okay. 96 watts. Sure, and we're drawing 106. That's okay. 5 amps. Oh, okay. Let's note that down. 5 amp is 120 watt on tester. 132 watts from wall. Okay, that's not bad. You don't win anything, sorry. So yeah, but can it do 6 amps? It can. Interesting. Did we pick the immediate winner for today? My testers are limited to, I think, 180 watt. So let's keep it at 5 amp, okay? And let's start with this tester, adding another amp. So now we're back at 6 amps. 7 amps. Okay. 8 amps. Oh, uh-oh. Okay, so it can't do 8 amps. It'll do 7 amps. Oh, that's kind of disappointing. It was going so well. It was like amazing. 7 amps is max load. After that, voltage starts to drop. So that's... I don't care about the wattage. Is it running hot? No, I don't think so. Let's see. Hold on. I can feel a little bit of heat, but not much. So we'll do it on camera. Oh, there's a component that's like 70 something degrees there. That's okay. Can be okay. But overall, the chassis is still nice and cool. There's something warm here, but that's 51 degrees. That's fine. Yeah, it's just sad because 24 volts is fine. But then... more... No, oh, so it even stops. Oh, it's blinking. Right, so... Yeah, okay. So at 9 amps, goes into hiccup mode. Yeah, I mean, I don't know why they wrote 12.5 amps here, because it clearly can't. Still, you know what I'm afraid of? I actually think this will be the best one we're gonna test today. But it'll do 7 amps continuously. We can try and give it like a little bit more. 0.1, 0.2, 0.3. Oh, yeah, no. So now, yeah, okay. Then it, yeah. No, I think I'm connected to the same group, or at least part of the same group. We'll see. So this one isn't bad, and it handles this quite decently. It's not getting hot. It just doesn't do what it says on there, which kind of sucks, because I paid, how much did I pay? 16 euros. Oh, okay. 16 euros for a 24 volt 7 amp supply. I guess that's not too bad. Okay. Well, we've left it running for a while, and it's still doing 7 amps. Let's call that a 7 amp 5-minute test. Okay. Voltage stable. I'm not using Chinese amps. Yes. Half the power. No, well, 12.5%. Or 12.57. I need to use the calculator for that. 7 to 12.5. It's doing 56% from what it promised it would do. Yeah. But, okay, let's try the cold start. So both testers are off. Okay, on. Oh, okay. Cold start 7A. Okay. Testers are Chinese though. Yeah, exactly. They're measuring Chinese amps. Okay. Well, I'm not going to stand and look at this too long. I think this is actually, it feels like a decent unit. It's not getting warm or hot or anything like that. Oh, yeah, okay. Idle power draws 1.5 watts. That's pretty decent too. It just does nowhere what it says that it can do. So, yeah. Okay. Next. So who said yes and is now disappointed? I'm actually disappointed. I thought this one, well, it did pretty okay. I mean, it did about 200 watts-ish, which is a lot more than the others did. Power still on? No. That's probably some capacitor that's draining. Okay, so we'll put this in the... it worked, but you know. Okay. So should we now take this tiny one? I really want to do this tiny one. Hey, Dutch Maker is here. Cool. Oh, can I wire this up? I don't have the right connections for all of this. Let me first look this up. This one is mute. This one has special features. So it's precision, mute, and dust proof. Whoa, high end. Whoa, it's like it has all the buzzwords. So let's try and find this guy. how to find this guy. I guess I could search for the buzzwords in my shopping history. I don't know. Well, one moment. Go to new tab. PSU. Nope. Power. I have too much in my history. Ultra thin power supply. That sounds like it. Yep, got it. Okay. So, edit. Number 2, we'll call this ultra thin power supply. Oh. Save. And I'll put that in my document too. And I paid, what did I pay? I paid 7 euros for it. Normally it's 9 euros. Okay? So we have a sub $10 power supply that supposedly is high-end, precision, mute, dust-proof, and will do 300 watts. 25 amps. I have my doubts. Now, well, my forks are not gonna, you know, are not gonna fit here. So I'll have to devise a plan. I think I'm gonna take a new AC cord and cut that up, because otherwise it's gonna get too complicated. Do I have one here? I think so. If it's way too long. Let me find a short AC cord, and I'll be right back. Because otherwise, you know. Okay, we have a short AC cord. So let's behead it. Do I have any good snips here? Yes. There. Don't need this part. Let's see if we can expose the leads. Let's move this back. Oh, one try. Okay, it has 3 wires. That's good. You never know. Oh, this one's over here. Okay. So let's see. How long should we? I don't know. Something like that. How's that? Let's see if that goes in there correctly. Yeah. Okay. Can't pull it out. Okay, good. So, let's wire this up. Everyone always tells me not to twist it, so I'm going to try it once, not to twist it. Oh, now things get interesting. The neutral is orange and the live is blue. I mean, I'm all for color-coded terminals, right? I try to make color-coded terminals on all of my products. But, I mean... so Earth is green. We can agree on that, okay? But neutral is orange? Well, I'm not playing, man. Neutral is going to be blue. Yeah, we're trying no ferrules today, Andy. Let's see how it goes. And then the brown will go into the blue. Does it say CE on it? Oh, CE, yes, no problem. I mean, this is all wrong. But no ferrules, but they're in there. So that's good. That's good. Now we need to fix this side. But I actually think I know how to do that. I'm going to borrow something I did earlier. Chinese excellence. Oh, Phil Bulldog is here. Nice. Okay, so we don't need those. We do need this. So we're going to bodge together a testing wire. Let's use one tester. Don't need this one then. And so we need to convert from fork terminal to a ferrule. And we're going to do that in a janky way. Because we're going to put this in here and then jam the screw in there. There. And now we have a perfect connection. Oh man, if this thing really does 25 amps, we're screwed. Oh, Dr. Z's is here. Nice. We're testing cheap-ass Chinese power supplies. This one's below 10 bucks. And we're building the appropriate testing setup. Hold up. So we do it like that, and then we squeeze it. No, screw went in sideways. There. And this one, there we go. As long as you screw it in tight, it's all fine. See, now we have the perfect wire divider, I don't know, whatever. And the other side already has ferrules. But of course, I wonder if this thing will take these ferrules, or even this wire gauge. I am doubtful. Oh, well, wow. Wow. So this is, let's see here, 16 gauge. Oh, that's not too bad. It still needs to do 25 amps over 16 gauge with one output terminal. But who knows? Maybe, oh no, this one didn't seat correctly. Maybe we'll be surprised. I mean, how do we know? Is this now? Yeah, okay. So that's fine. So there. This is the most jank we've hooked it up yet. But that's fine. It's perfect. I think it's very suited for what it is. Are we taking bets? Well, you can bet. I mean, I'm not. Let's turn this around. It's easier. There. I say this will do. Well, we only need one tester. 75 watts. Place your bets now. I'll take a sip of my drink. 75 watts. What do you guys think? Type a number in the chat. Oh no. Justin has 3 of those power supplies sitting on his desk. Well, then he might know what they actually do. Okay, 120 watt, 95, 200, and he says 200. That's more than the bigger one we just tested. 120, 110, 125, 57, 50 watts. I'm actually afraid he's probably right. Okay. Oh yes, with the special jewels on there, it'll do at least, it can replace high voltage lines. I hope you didn't pay much for them, Justin. Okay. Are we ready? Let's go down to 1 amp and let's turn it on. Okay. Oh, wow. We have a little... wait, I need to turn down the lights. Hold on. We have a little red status LED here. Oh. How nice. Okay. So it seems it's online. So it's actually, I didn't notice this before. It's actually potted. See the epoxy or whatever they filled it with over here and over here? So it's gunked up. Noise? That's probably why it's mute. So it doesn't make noise during PWM. That's a good feature. Okay, let's go 1 amp. It does 1 amp. Okay, 2 amps. 3 amps. Uh-oh. We're already at 11.8. But then again, we're running through a 16 gauge wire, but you can't really get more in there. So, I mean, okay. Okay, 5 amps. Wow, okay. I'm forgetting to take notes. 5 amps is 58 watt is 68 AC. Okay. I didn't note the idle current, but I'll do that in a minute. Okay, so so far it seems to be holding 6 amps. Okay, we're at 70 watts. I said 75, I think. 7 amps. Oh, it's still going. Okay. 8 amps. Wow. The little power supply that could. Of course, we're nowhere near the 25 amps. I mean, 9. I'm surprised. I figured it would have filled by now. Absolutely. 10 amps. Nope. 9 amps. Nope. 8. Nope. And 7. Okay, 7 it recovers. Go to 8. Go to 9. 10. Nope. 10 it's like, what are you asking me to do? Okay, so let's go to 9. 9 amp hold. 10 amp hiccup mode. So let's keep it at 9 amp for a while. But I mean, just judging from this, and this doesn't look too stable, this 300 watt, it says it right here, power supply is actually more a 100 watt-ish power supply. Yeah, exactly, Johnny. Well, don't forget the 5 watts. The little guys count. Yeah, lower voltage likely has a harder time. So it's okay. It's drawing 105. We're getting 105 watts, and it's drawing 123 watts. So either a lot is getting lost on this 16 gauge cable, which is a fair thickness, below 10 amps, you know, but it's not. Okay, it's warming up a little bit, not much. You're surprised it did this much, or that it didn't do more, mister? So let's take a look here. I need to move the tester away. Okay, so yeah. But the shell is pretty cold, 31, 32 degrees. Let's look at the bottom. Okay, the bottom is like 45, 46. That's okay. And it's holding at 9 amps. You're surprised they can make it so small and produce 100 watts. Exactly. If they would have marketed this as an 80 watt power supply, it would have been great. What temp are the screw connectors? It doesn't have screw connectors. If you have a blender that uses less than 100 watt, it'll likely work. It is starting to become warm though. Oh, this one. Oh, sure. I don't think that's a problem. Let's see. My janky ass screw my bob thingy. Well, the cable is warmer. The cable is like, oh, you can't see. So the cable over here is like 36, 37 degrees, and my janky construction here is a cool 31. So that's not the problem. But this one, oh, okay, yeah, it's heating up. No smoke yet, Greg E. We're just testing power supplies and seeing when they fail. So let's move the tester, sorry. Yeah, some parts are now 58, 56. Yeah, 50 degrees. So it's heating up decently. But, I mean, it's still going strong. Delivering over 100 watts. If they'd only just sell it with 100 watts or 80 watts on there for the same price, it'd be a great buy. But, I mean... something like that. 7 or 8 euros, so below 10 bucks. Yeah, because we're testing through all this cable. That is likely where the voltage drop is coming from. I normally say I can measure on the terminal, but I can't measure on the terminal, so I don't know. But likely part of that is the wire, because we're pushing almost 10 amps through it, so... And I mean, it is potted, so that is something. I mean, especially if you have it for like an AN Pentamini or some other PWM dimmer, having it potted like that can definitely lower noise. So that is interesting. Okay, it's becoming uncomfortable to hold. Interestingly enough, if you look at this drawing here, shouldn't there have been 4 terminals? I mean, Ow. Okay, it's becoming hot. But it's holding. It actually gets some cooling from the tester. Because, you know, the tester is blowing out air, so there's air movement here. Yeah, those terminals, I've looked at them before. I don't hate those. Okay, one more minute on the screen here, and then I'm calling it. Seems to be holding. Hey Arnold, well, welcome Arnold. Kind of their clamp style with a little lever here. Okay, well it did it. So now, let's see if we can cold start it at 9 amps. So, okay, let's wait for it and go. No, oh, it coughed a few times. So let's turn it off again, off. And let's cold start it. Okay. Cold start at 9 amps, sure. Cold start 9. Barely. But did it. Okay. And let's note the idle wattage. Oh wow. Idle power 0.3 watts from the wall. So when it's off, it's drawing 0.3 watts. Damn. That's tiny. One more try going 10 amps. You really... Okay, let's... Oh, no. Cold start. 9.1. 9.2. 9.3. 9.4. 9.5. 9.6. 9.7. Oh, no. 9.5. Yeah, it's not going to recover. 9. No. We need to go to 7. Then it recovers. 8. 9. So we can squeeze 110 watts out of there. Maybe. Okay. This power supply, it's 0.3 watts idle. Wow. That's the lowest I've ever seen. Okay, let's wait for the light to blink. To die. Oh wow, it's really warm now. How warm is it? Yeah, it's about 50 degrees. Yeah, it's okay. It's not too bad. Perry said 110. Well, then you win. Okay, let's get these off again. Okay. Unplug this. Unplug this. Unplug that. Okay. This goes in here. So we have 2 left. This one feels heaviest. We'll try and look at this one first. Oh, very different design. Oh, don't want to touch those. CHB 324. Oh, this one only does a European, so only 230 volts. 24 volts, 12.5 amps. It's also potted. Can you see that in there? Yeah. So they also gunked it up. Okay, interesting. Okay, let's get my other AC lead. Not this one. This one needs to go away. Yeah. Exactly, this one at least has style points. Oh, it has these smaller terminals again. That's not going to be a problem on this side, but it might be on the other side. We'll see. Yeah. Okay. There. That's good. So does it have the same small... it has the same small terminals on this side. Well, let's see if we can get tester 1 in here. No. Nope. Why do they make them so small? We'll have to modify this a little bit. Probably gonna wreck it, but we'll see. So let's squeeze this together a little bit. Just a little bit. It's so hard to go... okay, what? We have one. Okay, let's do the same on this side. Try not to squish it. Okay. I think I got it. Oh, yeah, we got 2. But now I need to deconstruct my janky... So Andy thinks 200. I think... I'm going to go lower. I think 125. What do you guys think? 132. That's oddly specific. Okay, so let's see if I can fit 2 more. See, that's what I'm afraid of happening. Pushed it just too far. Let's see if I can fix that. Maybe. Huh? Okay. Last one. Maybe that's enough. I think I can squeeze it. Come on. Oh, there we go. There. So these now are all attached securely. I'm going to look it up first. Let's plug it in there. Look it up. It's a black one, so maybe that's easy. I think it's this guy. Yes, got it. Nice. Okay, copy. I paid $13 or €13.18, so a small $15. 3 black 300-watt idle power. Okay. So let's copy that into the YouTube description. Save. Okay. Idle power. Let's. Oh, wait. No. I almost forgot the protections. There. Let's turn it on. Okay. Still dropping. Okay. Idle 1 watt. Still going lower. I am drinking a Sprite. Okay, idle power is at 0.6 watts. No, okay, no, it hovered back up. Okay, 0.7 watts. That's pretty good. That's pretty good. The output, for some reason, is only 23.8 instead of 24. Not sure what's up with that. And there's no potentiometer I can turn to fix that. No potentiometer. Okay, so we're missing 0.2 to 0.3 volts to start with. That kind of sucks. But let's go for it. 1 amp. Two amp. Okay. 3 amp. 4 amp. 5 amp. Oh. What? 4 amps. Okay, it recovered. Wow. What a shitty power supply. Okay. 5 amp hiccup mode. Let's see what we can get as the highest. Oh no, the fluctuating. Oh. Okay, so let's try 4.5 amps. Okay, you can do 4.5 amps sustained. It is 107 watt DC, 121 AC. Okay, let's see if we can do 4.5 amps for a while. Biologische huiswijn rood literfles van de Plus. Okay. No, I'm actually very boring. I don't drink alcohol. I don't like the taste of it. So we'll leave this running for a little bit. Wow, that's horrible. It says it does 300 watts and it won't even do 100. Really. That's just bad. It's not even, it's just bad. If it does only 1/3 that it says on there, there is no coil wind, but I'm not doing anything. This is a very constant load, so they forgot the dot after the 30. Exactly. So let's see if it's heating up. Let's see here. We have something inside that is 63 degrees. That's okay. Part over here is 50 something degrees, but there's no component there. Might be a chip under the gunk. I don't know. There was probably a chip under the gunk. Yeah, other than that, it looks fine. So that's likely some IC. So let's put my finger right over it. So over there, some IC over there that's gunked up, that's getting warm. And then over here, somewhere over here, yeah, it's probably also some kind of IC. What's connected to the DC side? My load testers. These are my load testers. Oh, I didn't put a link for my load testers in the description, huh? So while we wait for this lengthy test, load. Oh, I think it's actually on Quinled.info. Tools. Testing tools. Yes, it is. Okay. So let's put that in the video description. Testing electronic load tool. There. Save. Okay. The electronic load is linked in the description. So let's see. Yeah, we'll take a look. Nope. Well, I have to move the tester out of the way. That's pretty okay. Doesn't feel too hot to the touch either. No, these are DC load testers, so they test the DC side. And on the AC side, I measure with a PR10. That's also linked in the link in the description. Those are nice. How accurate they are. Well, I don't really know or care how accurate they are. Let's say I don't care if they're like 100 or 200 or 300 milliamp off, or the voltage is like 0.1 or 0.2 volts off. Because I generally test like 5, 10, 20, 50, whatever amps. So then, you know, the margin there is a lot higher. And same for the voltage, although the voltage, the way I'm measuring is incorrect for the voltage, because I'm using a single wire to measure. Although these are dual wire measure capable, I've hooked them up with a single wire and then bridging the two terminals. So I'm not measuring the voltage correctly, because I'm seeing the voltage drop that's also in the cable. And officially, of course, that's wrong. But then again, I can just stick my multimeter on the outputs and then measure the voltage. So if I want to have an accurate voltage, I use my Siglent desktop multimeter, which is much better for that. But as a load, being able to generate like 3 amp, 5 amp, 10 amp, whatever load, these are great. I mean, we're doing 4.5 amps. I guess we could verify that. So let's take I have a clamp meter, which can also do DC. over here. Let's 0 it, and then, no, not hold. Let's light it up. And let's see if I can measure. Yeah, I'd say that is pretty good. We're officially pooling 4.5 amps, and it says 4.5-ish. Right? So, I mean, this isn't meant to measure milliamps or something like that. Let's test the positive side. Yeah, a little bit lower, but I mean, for me, for the testing I need to do with them, that is absolutely close enough. If you need it better, though, you'll have to buy much more expensive equipment. So, I mean, even this guy isn't like super highly factory certified, calibrated, whatever, but good enough for what I do. I mean, you can spend an unlimited budget on tools and have the best tools out there, but maybe the tools that are good enough for what you're doing is fine too. So, yeah. Okay, well, I'm calling it for this one. We have one left to test. So, sustained, it did 4.5 amps. No, not. I mean, they might be 100, 200, 300 milliamp off. I figured it's actually much lower than that. If you can judge it from these 2 meters. But they're pretty good. I like them. But we have another 100 something watt-ish supply. Doesn't get very warm. Yeah. This one, basically... So, this one basically does the same or better than this one. Why? What's going on? I mean, this one is at least 3 times as big. Yeah, maybe, I don't know, 2.5, 3 times. It's also higher. It does about the same. Okay. Boop, boop, boop. My Starfield display? What? It's meant to be fire. I guess I should reverse it, huh? Okay, let's see if I can get my wires back. Yes, good. So, that was power supply number 3. Let's fix the display. Hold on. Let's go into each segment and say reverse direction. There. Can you guys see? Yeah, okay. Reverse direction. So now they're going from the bottom, but my chair is always in front of that. And I changed it to orange for Johnny Bergdahl. We can change it to orange and teal. It's not really visible, huh? Rainbows? Whoa, that's trippy. Let's go to fire. There. Now we have the official normal fire. We do no cooling. We have lots of spark rate and boost it. Okay, so now we have a nice campfire in the background. Cool. Okay. Last one. Last power supply. And then we get to take a look at the secret. But the secret we kind of still have to build. Because I received it today. And I haven't tested it yet. Ooh. Let's stick around for that. Okay. Oh, I wondered about this one. Yes. Wait, this looks the same as some other type. Have we tested this one before? No. Oh, okay. Okay, so I need to look this up. I need to not get shocked by AC. So let me try and find it. Nope. Yes. It has 3 years warranty. Oh, no, wait, misclicked. And I paid 21 euros for it. Holy shit. Most expensive one yet. Save. No, wait, copy. Paste. So I paid 21 euros for this guy. So place your bets now. Okay, it has, at least it has beefier barrier terminals. That's good. And the design also looks a lot better. Neutral. Yeah, looking at it, we see a nice capacitor here, or a fuse even. Is that a fuse? I think that's a fuse. Let's see. Let me get my my tool. Yeah, that's a fuse, all right. That is a 4 amp 250 volt fuse. An actual fuse. Wow. Let's see if can all kinds of stuff inside. Well, we'll see how it does. Okay, let's unscrew these. Nice terminals here, better than the other one. Can this be the first one that did 7 amps? Who knows? It says it'll do 12.5, just like the other one. So let's see. I need to open this fork up again. There. Hey there, AK Storm. Did I miss any fireworks? Not yet, not yet. We're testing the last power supply. Who knows? Okay. Last one. Let's turn on the power. Okay, let's give it a little bit to idle. It's also 23.8. Not sure why they can't really set it to 24 volts. Is there a pot here somewhere? Let's find it. No, there's no adjustment pot, so we can't change the voltage. Okay, we idle at 1.5 watts. That feels somewhat familiar. No, there's no voltage dropper and there's no load. Okay, let's go for it. 1 amp. Okay. 2 amps. 3 amps. More 4 amps. 5 amps. We've already passed the other one. 6 amps. Okay. 7 amps. Oh, we're at 7 amps. And we're at 166 watts. So I'm gonna move to the second tester. 8 amps. 9 amp. What? 9 amps? Can we do 10 amps? Is it possible? 10 amps. It is! We're doing 10 amps on a 12.5 amp supply. What is going on? Okay, more. 11. Uh-oh. Uh-oh. Nope, nope, nope. Nope. It might be compensating a little bit, but these are very thick wires, so there's not much voltage drop. So we're doing 10 amps. Yeah, it might be compensating a little bit for the output load. So, wow, okay, 10 amps sustained. We're getting 166 plus 71 watt is 260 watt AC. Okay, so let's see, 166, 71. So we're getting 237 watts. And we're pulling 266. Yeah, let's leave it running for a little bit. It's currently at 10 amps. Because we have to let it, you know, soak in. Let's see if I can feel anything. Oh, I can already feel stuff. Hold on. So, moving the testers out of the way a little bit. Oh, something over here is 100 degrees. What is that? Oh, it's some kind of resistor, I think. Let me see if I can find it, see it from this side. Yeah. There is some resistors there that are over 100 degrees. 106. Is it the resistors or is it the cooling block? No, it's the resistors. Okay. So let's take a look at the rest. Oh, wow. Okay, there's something here that is 114 degrees. Oh, no, wait. It's 140 degrees. Is it the fuse? No, it's not. It's, is it? What? It's something yellow. Is that a capacitor? I don't know. Could be. I don't know my AC. Oh, I know what it is. It's a varistor. So we have the fuse. Ow. Let me try and show you. We have the fuse, and then there's a black capsule kind of through-hole thing there. I believe that is to limit inrush current. So that is hot is normal. That's okay. It's kind of like a PTC, but then different. Yeah, so this side, let me put it on its side. This side's really warm. I will not take it off while it's running. And I think it's stanced in there, so I'm not sure it'll be easy to remove. Oh. So it's warm, it's 45 degrees, and there's a hot spot here with 52. 46, 47, 48. Okay. Dropped it, now it's broken. I mean, it's doing it, but some stuff in here is getting pretty warm. Let's give it a few minutes. Let's see, on the timer we're now at 28. Let's give it until 26. And then we'll try a cold start. I'm gonna chill next to my fire here. Yeah, in regards to voltage drop, if you look at the 2 meters, they're connected using the same type of 10 gauge cable, so that's 5.5 millimeters square, so very thick cable. And this one is pulling 7 amps, and this one is pulling 3 amps. But they're coming from the same point, so the voltage over here will be exactly the same. But because of voltage drop, because of the cable, even though we have a 10 gauge cable, this one is seeing 23.79 volts, while this one is seeing 23.82 volts. And that is just the voltage drop on the cable, because they have the same voltage over here. So voltage drop depends on load. You can't measure voltage drop with no load, basically. That is correct, Danny. If you use a 22 gauge or a 14 gauge with no load, the voltage will be exactly the same. But then if you put a 1 amp and then a 5 amp load on there, you'll see that the 22 gauge will start to drop a lot more voltage than the 14 gauge. Well, these meters aren't exactly specific, but we'll see when we turn it off if there's a difference there. In theory, there isn't, though, but it depends on how well they're calibrated. I mean, I can turn this on. Hold on. One moment, please. Oh no, it's all messed up. Hold on, almost there. Yeah, okay. Okay, so now we have the multimeter on screen, and if I measure on the terminals here, you'll see that we get 23.865, okay? And then if I measure over here, you'll see that we get 23.815, so we lost 50 millivolts. And over here, 23.4, so we lost less. And we can actually measure, let's see, from here to here. Does that work? In theory, that works. Other way around? No. Yeah, that's not accurate. Okay. When I turn it off, the voltage should be the same. Yeah. So let's call it. It did 10 amps for, I don't know, 5 minutes. So let's turn it off here, and let's turn it off here. And now these voltages will differ slightly because of calibration. If we measure on the device itself, we get a 23.78. And then over here, we get a 23.78, and then over here we get a 23.78. So the difference we saw was just the voltage drop on the cable, basically. Yeah, true, Philip, but I think you need to add positive and negative together, because it drops on both sides, and then you get the real voltage drop. Yeah. So you can actually measure voltage drop like this by measuring the cable. Currently, there is no voltage drop between this point and that point. And if I then start the power supply, you'll see a voltage appear. And this basically says there's 21 millivolt of drop between this point and that point. And if you turn off the power, the drop goes away because there's no drop anymore, right? So let's see if we can cold start 10 amps. Let's see here. We can. Okay, that's pretty good. Crash course in voltage drop, exactly. So this is a, well, at least from these measurements, decent 24 volt supply that will do 237 watts ish, which is about 10 amps of its 12.5 amp rating. I mean, let's see what percentage that is. 10 divided by 12.5. So it does 80% of its rated capacity. Well, I can push it. What do you mean push it to the max? If I go any higher. Oh, wait. It still does it? Oh, let's go. No, okay. Oh, it'll do 11 amps. It'll do 11 amps, but with sagged voltage. See that? Okay. I'm calling this one. Yeah, I mean, I wouldn't run this guy at these loads for all too long because it gets way too warm. Exactly, Danny. You can't really run this one at 10 or 11 amps. Maybe 8 amps would be okay. I don't know. Yeah, again, it's not a mean well. It's not going to do what's written on there. But it'll do about 200 watts or so. So that's pretty good. That's the best one so far. And idle, it draws 1.5 watts. That's decent. Cool. Okay. Ow! Okay, it's warm. It's certainly hot. Oh my god. One moment. Yep. Yeah, it's quite warm. It's okay. It's not pleasant to touch. If you want 300 watts, no, buy 900 watts. We tested those in the last stream last time. They did about 80% of their rated claims. So they weren't too bad. They weren't perfect either, though. Andy? This guy's warm. Woo. Ah, I'm stuck. Okay. Okay. On to the pile of tested Chinese power supplies. Well, now, we've already been going 1 hour and 45 minutes. Okay. It is time for the secret. Because this time, the secret is going to take a little while. So I need to clear this off my disk. Well, I could test those, Neil, but I'm pretty sure those will do what is rated, what they're rated for. I can't really go around testing all power supplies in existence. What? But I'd say those will generally do what they're rated for. So, are you ready for the secret of today, which we have to build? We need this box, and then we need these guys, and then we need this box. It's like you've bought Quinn LEDs and you're unboxing them for the first time. Right? So this is the genuine. Let me close the voltage meter. Don't need that. Oh, maybe later. Okay. This is the genuine Quinn box experience. So in here, there is these tiny little guys. Let me see if I can get them out. Of course, the wrong way to do it. First off, there's this guy, which are production samples. And this is the Quinn LED I2C Temp SHT30. So these can either be used with a Stemma QT cable, or they can be plugged in using a socket header on some of the boards that are out and coming up. So we'll leave that for a bit. And then we'll unbox this guy. First we get a nice little card here. So it's a brain board from the Dig Octa system. The multimeter off screen, okay. There. So you get some standoffs. We'll be using those in a minute. You get the new V2 brain board. Is there a gap in here and so I can tear it? In theory there is, but I can't see it. Okay. So the new V2 brain board you get an antenna with a pigtail connector, and you get all the screw terminals that go onto the V2 brain board. So let's plug these in for fun. All these screw terminals have a plus, so Phillips head screws instead of flat head, because I don't like flat head. And here we have a V2 brain board, and you can identify that by the smaller jumpers. There's a jumper over here, and there's a jumper over here, and of course it's written over here that it's the V2. They don't have a Phillip head, yeah. And there is these expansion pin headers here, and you can disable the SD card slot and its resistors using this jumper. You pull it off, and then you can actually hook up a digital microphone if you want to. Okay, but the real secret today is what's in this box, because this should be releasing soon, because this is also a production sample. It's always interesting getting the other box out. I haven't yet reached Apple level of unboxing prowess. So you get a little box here which has, again, all the standoff. Maybe I shook it too much. Oops. It has all the standoffs you need, all the screws you need, etc. And I kind of shook it too much, so they came out of the baggie. That is okay. And it has all the terminals you need for a Power 5. But this is a special Power 5. Oh, this one has that little tear gap. Okay, the tear gap didn't do me much good. No gummy bears included, sorry. Because this, if we take a closer look at that, it has the new logo, which is very nice. This is a Power 5 HV. It also says it on the back, Power 5 HV. And this is my first production sample that I'm looking at. So far, the silkscreen looks excellent, and the logo is coming through very nicely. And this all looks great. So this, oh no. Why am I always discovering things when I'm on stream with you and looking at a production sample for the first time? Here it says 5 to 24 volts. That's wrong. It's supposed to be 24 to 48 volts. What the? How did that go wrong? I know I had that right in samples. Because everything else is right. So this is 10 amp, 10 amp, 10 amp, continuous 30 amps, Q power post compatible. This is all right. There's a very nice notice here. Hot plugging, output power not advised. We should have a voltmeter that can do up to 100 volt. Haven't tested that yet. Yeah, so this board is 24 volts to 48 volts, not 5 to 24 volts. Damn it. Well, we might be able to fix that with a sticker. There's always something. as long as that is the worst mistake that's on there, I'm okay with that. Damn it. Okay. Anyway, let's give it some feet and then mount the brain board. So to give it some feet, I'm going to use these tiny little standoffs and these screws. Do we have all the same length screws yet? No, we have smaller screws. Oh no. We'll use these, that's fine. Because I like having the board off of the table. Oh, we do have multiple length screws. Okay, well, it doesn't matter. It's fine. You can use either for this part. Oh, oh no. Okay, found it. What? Who got shunned from testing? No, I still do some testing, but for some stuff it's just not needed. Okay, so now we have the power board from the table, so it has little legs. That's also how you can mount it in your box or whatever. It doesn't have components on the back. The Power 7 does. But still, it's better to have it lifted off of whatever surface you're mounting it on. So then we take the back from the brain board. No, actually, we're gonna, since this is my first sample, we're gonna hook this up and see if it explodes before I hook up the brain board. So we're gonna take my my variable power supply. Red always goes on the side with the fuses. The in one? Yeah, I guess. I think I found that with just a space there, it didn't look too great. Because these are in boxes and these aren't. But, yeah. Yeah. Okay, so let's first turn it on without a power board or a brain board on there to see if it explodes. Let's see, where is my... I need these leads. And then I need... Oh, that's a good question. I don't know. Let's see if this is the right one. I think so. Where's my safety glasses? I'm not sure I'm turning on the right power supply, but we'll see. Nope. Oh, nope, that's the wrong one. No, wait, that's the right one. Oh, but it's a 24 volt supply. Okay. Well, at least the 24 volt supply is working. I guess that's a test. Let me measure what we have on the output here. Yeah, that's perfect. Okay, so that's not the right... This is not the power supply you were looking for. It's probably this cable then. Yes. Okay, good. Okay. Let's go there. So you have these pluggable terminals, and it's not advised to plug them in and out while the board is powered on, even though they're pluggable terminals. Because of the high voltage, this can give a spike basically, and it can kill other stuff on the board. Okay, so let's go 48 volts. No, 1 amp. That's already pretty a lot. And I'm gonna put this plug in. And I'm gonna put this plug in. I'm just gonna put all the plugs in, I guess. So the problem is with 48 volts on there, if you're hot plugging it, it gives a really large spike which can kill stuff. Not immediately in my testing, but at some point it will. So let's see, 48 volts and 1 amp. Go. No, wait. Not go. I don't have the right cables hooked up. Damn it. My brain has stopped thinking. If you're wondering why I can just turn on random power supplies on my desk, that's because all the loose leads I have, I basically put into these kind of blocks, so that even if I do turn on the wrong one, it shouldn't be a problem. Okay. So let's hook this up. Now, I did some last minute silkscreen changes before this went into production. I clearly missed something. Okay, 48 volt, 1 amp. Let's turn the multimeter back on. There. Go. Nice. The voltage meter did not explode. Because that was also a last change. So we changed something in there. So we have 48 voltage-ish coming in. And we have 48 volt on the output. But interestingly enough, we should have what? Yeah, okay, sorry. 15 volt on the orange plug. That is because we should also have around 15 volt on the Q power post. And that is also correct. Can you tell looking at components rated for 48 volt? Yeah, basically then all the components on the board have to be rated higher than that. So for instance, these big caps here, they're rated for 80 volts. So that is well within the limits for 48 volt. And then all the small capacitors and other chips on here and things like that, those are all rated for 60 volt, 80 volt, or even 100 volt. Like these fuses, they're rated for 125 volt. The diodes are rated for 60 or even 100 volt. I'm not sure from head. I can look at the type number. Yeah, they're rated for 100 volt. So everything on here, like this DC-DC converter, is also rated for 60 volt in, so that it can make 15 volt. And why 15 volt? Well, that's for what we're going to do now. The brain board can only handle between 5 and 24 volt. But because now this power board has a DC-DC converter on there, which can make about 2 amps of 15 volts, so that's 30 watts, so you can still build a pretty large stack of brain boards. You can still use a max 24 volt brain board on a power board that does 48 volt. That is the advantage of having split logic like this. So let's put on the brain board. Power is off. These are PTC fuses. So they're auto reset fuses basically. And I've done a lot of experiments with fuses, and I've deemed them acceptable for the input fuses here. But for the output fuses, I've still gone with, well, traditional style fuse, one single blow fuses, I guess you could call them. Because in my testing, I felt that worked better. Yeah, so if you have some of those 48 volt pucks, I have them next to my desk. We'll take a look at those in a minute. You can use those, or if you want to use those 36 volt Govee pucks or something like that, you can natively use those with this board. Nothing else you need to do. How would you measure the amount of stackable boards? Well, in my guides, in my written guides, there are guidelines for 5, 12, and 24 volt. How many boards you can stack. I guess I need to add 48 volt. But basically, each board uses a bit of power, but the amount of power that is allowed to travel through Q power post is limited to about 1 to 1.5 amp. So that will determine how many boards you can run. But since we're running at 15 volt, you can run a decent amount, like 5 or 6 if you really wanted to. Yeah, so on normal power boards, this one is the same as the input voltage, but then it's 5 to 24 volts. On this board, it's always 15 volts. So that is indeed different there, Andy. Because this power board is doing power conversion. The refresh rate or the frame rate? They're WS2815s, so I think they're about 2 kilohertz PWM. And the frame rate, I can check the frame rate. Info. We're currently at 92 FPS. Yes, Q power post normally is also the same voltage as you're putting into your power board. But in this case, because we have the conversion on the power board, the brain board is also getting 15 volts. That's why we can run a higher voltage power board. So then we have this little guy. We're going to plug that in. It says align here and over here. It's tiny, but it also says align. So we can align that and plug it in. Now you can reverse it. That's no problem. It won't die. It just won't work. Okay. So that just goes in like that and then sits on top of there. And the temperature sensor is actually on the bottom. But then you can add a temperature sensor to the new V2 brain board because it doesn't come with one shipped right now. No, you can, Philip. You can connect the power boards, or even the power boards you can stack all the way, even this one, and you can mix and match voltages on those power boards. That's no problem. Yeah, so you can have a Power 5 HV running 48 volt, and then have a Power 5 running 5 volt and a Power 5 running 24 volt, all in the same stack, all connected. No problem. Okay, antenna attached, and we also have some Ethernet. So you can stack everything to everything still, even with this new board, and it should still all work fine. Yes, highest voltage wins. Yeah. So that 24 volt board will be delivering the most power. Until it sags because of the PTCs and diodes between there, and then maybe another board will jump in, maybe not. I've never tested that. A DIN rail case, I guess you could make one. It's not really designed for that. Okay, so we have Ethernet, and we're still at 48 volt 1 amp going into the power board. We don't have any power connections to the brain board, only through Q power post. And let's turn that on. Okay. It's always nice when it works right out of the box. Okay. That's a relief. So let's measure what voltage is coming in. So we have ground. All these side screws are ground. And this one, yeah, we have 14.7 volts coming in through Q power post. And that's correct because there's diodes and other things in the way there. And there's now a little bit of load. So that will lower the voltage from that 15 volts we had before. We can still measure 15 volts on here, I think. Oh, 14.9. Okay. But yeah, having a little bit of load on there with the diodes and the PTC fuses and things like that lowers the voltage slightly, but it's meant to do that. That's fine. As long as it's stable, which it looks like because we have a blinky Ethernet light. So that's always a good sign. We have 48 volt, 48.2 even, on the display here. So that also works. And there is a new feature on this power board because it's doing something new. If you look at the LEDs over there, when you can. No. So it says board power, that is on, and Q power post is also on. And Q power post is the 15 volt, and the board power is the 48 volt. So, yeah. Well, this is absolutely from the ground up design. So, yeah, I like this system the best too. Sadly, it's also the most expensive, but, you know, you get the much nicer terminals and much more functionality. So, yeah. Okay, that all seems to be working great. I designed everything from this whole system by myself, yeah. So I do all the circuit designs, circuit layout, PCB layout, manufacturing, testing, it's all done by me, yeah. Correct, Justin. Or, yeah, Justin, I guess. Yeah, so if you have multiple power boards in the same stack, they can be a different voltage from a different power supply. And you can share a brain board or a stack of brain boards, and they'll all automatically work together. So you can use an output from this single power board or brain board, and then have an output power from 5, 12, and 24 and 48 volt. All fine. So let's turn power off. It's not drawing a whole lot. That's good. And let's take these 48 volt pucks we have. Or I have. Oh, wow! They still have the right connectors on there. That's nice. Well, the temperature sensor is always a little bit of an add-on. What temperature is dangerous? I don't know. If it says 80 or 90 degrees, something is probably wrong. Yeah, it's hard to say. Sure, US 2904 should be fine, I think. Those are 24 volt pucks, I believe. But yeah, that's fine. So we can, I've already pre-wired this. So we can wire this up to power. And then we can wire this up to ground, or to data. Let me move the data line. Well, you have to pay attention that you put in the right LED into the right voltage, but other than that, it'll work fine. You can always read the display on the boards, because it'll say the actual voltage that power board is running on. At some point, Andy, at some point. Although I am very happy to see that the Diff Solo, but especially also the Diff Advanced, seems to be very well received. I've been having some very nice comments on that, so that's been great. Last W firmware drops blue light? What? I don't know what that means. Okay, so now we have some pucks connected to. Well, you literally saw me unbox these just now. Let's turn it on. Okay, so we're getting wrong colors, but we are getting output. So let's go to the IP that the board got. Let me check. Okay. 10. One moment. I think I misread. Hold on. Oh, 112. Okay. Yeah, it's still running version 14 of WLED. We haven't started flashing newer ones yet. We'll probably change it once version 15 comes out. But let's see if I can share my screen here. One moment. There. So in there, we need to change the configuration. I'm first going to delete all the channels we don't need. So let's and disable the brightness limiter. So let's save that. Okay, so now we have one channel on GPIO 0. Okay, and I think we need to set it to. I think this one. Yeah, and then the colors are still wrong, but we are getting uniform colors, so that's good. Let's try RGB. Yeah, so now it's orange. And if it's orange, we know it's good. Because let me dim the studio lights. Let's see. Can we see? Yeah, okay. I can disable the multimeter. So now if we go to red, turns red, blue, turns blue, green, turns green. Let's turn off the color, turn on white. Yep, and we get the white diodes. Next, because the if you look in the puck itself, there, you can see that the white diodes, white channel, they are different diodes than, for instance, where the colors come from, right? So there's green, red, blue. So they're actually different diodes on the puck. Cool. Okay, let's do some blends. Blends. Ew. Awesome. So that was kind of the secret of today. I'm lost for words. Unpacking a Brainboard V2 and a Power 5 HV, which stands for high voltage, which is thus suited for 24 to 48 volts. We're feeding 48 volts from my variable power supply into the boards. You can see the 48 right there. And we're driving 48 volt pucks straight directly from the board. Instead of having to do things with buck converters and other stuff, the board does that all for you. Zombie mode? What? So there isn't really a difference. We compile in some user mods and we preset some pins, but that's basically the most things we change. So you can use the normal firmware, but then you have to use the pinout guide to set everything yourself. And you might miss a integration such as the temperature sensor or audio reactive or things like that. Or you can flash our build and then it's preset basically. Yeah, no code changes, exactly. So yeah, this seems to be working. I am very happy with that. Because I always put myself for the blog. How do you say that in English? I don't know. I always test myself, I guess. Because this is literally the first production samples I've got. This one. And I didn't test it before. I really did not unpack them before this stream. So, I mean, this is the first time I'm using a Power 5 HV from the production batch. And, you know, you could say, it's kind of dangerous to do that on stream if it doesn't work. Then again, we find stupid mistakes. But at least it works fine, so that's good. It is a work in progress. They have been ordered, but it'll take at least a month before we get them. And then we also will spread them to Dr. Z's next to having them in the Allnet store, and then at some point they'll go on sale and you can buy them. So that project is moving forward there, Iman. So that is, yeah, that's looking good. It must have felt like a Christmas package that could only be opened on Christmas evening. Receiving something you've designed and built and tested yourself and then said, let's make 500 or let's make 1,000. It's always kind of scary when you're testing it for the first time, because if it doesn't work, I've just wasted all profit for the whole year, basically. So yeah, it's a bit scary because I don't make a lot of profit, and if I screw up on a batch of 500 or 1,000, hopefully it's fixable. Sometimes it's not. Yeah. GTN 1 and 2 on the brainboard. What's that? GTN? Oh, I think you mean BTN over here. Yeah, you mean the buttons? Oh, hold on. Let me zoom in. So over here, I don't want to take 48 volts there. Over here we have a button and a button 2. And, well, you can actually see it on the card. Although this card hasn't been updated, basically the port layout didn't change. Oh, it's not that readable on the card. Oh, okay, there we go. Button 1 terminal, button 2 terminal. Those are pulled high. It also says that. So it has ground and the button on there. So you can connect, well, a button or a switch. But you fixed AN Penta Mini. We did some last minute changes on that, yes. But that, I mean, I'm not stupid. The first batch is always a lower amount than next batches. You know, I pay more, but I pay a lot more if I waste money. So, but luckily we were able to fix those. Yeah, that was good. But we're already on the second or third batch for the AN Penta Mini, so now it's correctly done from factory. Not so much, Nunsa. I don't have any plans in that regard. Now, let's take a look at this temperature sensor, and that's the last thing we'll do today. I don't think the user mod is on here. No, it's not. So we're going to turn this off. I'm going to turn this on. And we're going to use my own installer website. So on, where is it? We're going to use the install Quinled.info. We're going to go to the dig octa. And we're going to say we have a temperature sensor installed. Yeah. Probably we might do a sticker, yeah, something like that. I don't know. I mean, something like that I can laugh about. It's okay. We'll fix that in the next batch. I believe they do, Alexander. You should check on Aliexpress. I believe they even make 48-volt ones. I have a box up there I could try and take out. It's kind of a mess, though. Let's first look if the temperature sensor works. Yeah, I haven't decided on that yet, Philip, if we just want to include the mods but have them turned off, or we don't want to do that. I mean, I don't want it to cause glitchy behavior. So, yeah. One other thing we also need to do, we need to make a firmware for the V1 and the V2, because the V2 actually has a 16 megabyte ESP32 on there instead of the normal 4 megabyte. Now, the 4 megabyte flash works just fine on the 16 megabyte, but, you know. Installation completed. Okay. Let's turn that on again. Oh, let's turn this webpage. Yeah, we can just go here. On. Okay, so now we flashed using USB. So we need to reset everything. So let's make these go away. This was SK RGB. Turn this off. Okay, they're orange again. User mods. Enable the temperature sensor. I2C should be pre-configured, so you don't have to fill that in. Save. And probably we need to reboot. Yeah, let's reboot. Reboot WLED. Yeah, anything for sale right now is a V2 brainboard, Alexander. No worries there. So, AllNet and Dr. Z's, they're all V2 brainboards. Did it not enable? It did not enable. Okay, save. Did I plug it in correctly? I think so. Seems we're not getting a temperature sensor today. Yeah, for some reason it's 14.2. I would have expected 14.3. Let me download the newest 15. Just for fun. Margie, check out the last video. That is about that topic. Sound reactive. So let's see if the temperature sensor works in this version. Save. does not seem to want to work. Okay, let's turn it off. Let's fiddle with it. It should be good. Yeah, but there is a thing when it doesn't want to enable. It's probably not finding it for some reason. No, we can check out another one. See if this one maybe has an issue. Let's turn it off. Okay. Yeah, no. If it can't find it, it doesn't enable. I've seen that before. Use a mod. Save. Nope. Oh, Denny Janmaat, thank you for the 11 euros. That is very much appreciated. It seems we cannot enable the temperature sensor today. That kind of sucks. Now I wonder if it's the plug-in boards or if it's the Dig Octa. I think I need to open up this AN Penta Mini for my prototype board. Let's check that out real quick. Sure. So those are I2C. Okay. Can you see? Yeah. Oh, okay. The chat's in front of it. Okay. And then down here we have the temperature sensor. Oh, well, you can't see that. Sorry. Oh, nope. Sorry. This isn't the right one. No temperature sensor in here. I know I have one where I had an internal temperature sensor. And I know that one is working. Later, Danny. Thanks for joining. And thanks for the donations. It is an SHT30, yes. I think I need to pull one from my desk. It will be Quinn LED branded, Imam. That is your mod, yes. Exactly, Andy. Okay, let me get something real quick. Hold on. Okay, I've got my, where is it? There. My prototype, we soldered together on stream. There should be an NTP server on my network. But it probably tries to get, oh, NTP is turned off, okay. Okay, well, I didn't set the time zone. Anyway, let's turn it off again. And let's put my prototype on here. Yeah. Turn it on. Okay, let's turn on the user mod. Interesting. So, temperature sensor, no worky. Oh, wait. Oh, no. I'm not sure what outcome I wanted from this. But we now have a temperature over here. Let's see if it changes. 31.6, 36.6. And it also changes. So that means the brain board is working. Okay, so now we have a working situation. Okay, let's take off my prototype sensor and put on the production sensor. Oh, I didn't change anything. I just put on this different sensor. Okay, config, user mod. Okay, it's still enabled. Good. It would seem my sensor boards are not working. Because it's still enabled. Oh man. And this is the whole reason I pulled them off of the brain board. The last batch of the brain boards we had, the temperature sensors were all broken. In the same manner. So I was like, okay, I'm done with this crap. I'd rather design a modular board, and then if we have an issue with it, at least it's an add-on board and not the main board, basically. So let's change nothing. Depower. Let me... I'll take off the production sensor. I'll put on my prototype sensor. Yes. Power on. Yeah, immediately there it is. Okay. So, likely the assembly house screwed up all the temperature sensors again. Oh, man. I don't understand what they do to them that they die. Yeah, this one's working fine. And this is one I built here. I mean, it's not like my soldering techniques are the greatest. I think we made 250. So let me compare this. It's on in the right orientation, it just doesn't work. But I don't understand what fries the chip, basically. Yeah, it's just not there. Oh, no, wait, back. And if I turn it off, take this one off, put this one on, turn it on, it's just for temperature monitoring in a box if you'd like to have that. Okay, let's refresh, info, it's right there. Okay. So whatever issue we had on the previous brainboard batch that killed all the temperature sensors again on the add-on board. Oh man. No, I know what's going on with these chips. I've had this issue before. I have 5 samples here. I don't know where I have the others. I'll have to look that up. No, Philip, I've seen this issue before. I know what's going on, so I'll do that off stream. I don't feel like doing that on stream. I'm already way too happy that you know, the unboxing of my 48-volt power board and then hooking it up, building a dig Octa and running it worked great. So yeah. It's okay, stuff fails. I mean, it happens more often than you think. That's the things you don't see behind the scenes that I deal with. That's okay. So I just have to kick the production house again to fix their shit. But at least this is working great. If they're all dead, I'll try and get them and we can, you know, put them in the wall of shame. Okay, so speaking of stuff that isn't working, should we blow a fuse? Let's blow a fuse. I feel like blowing a fuse. I mean, shit isn't working, so let's blow a fuse. Okay. Oh wait, let's set the power supply to 10 amps. Let's put on the safety glasses. Yeah, I have plenty of reserve fuses, that's fine. Okay, so the power supply is set to 48 volt and 10 amps. And, let's see. Let's zoom in a little bit. I wonder what happens with the voltage meter. I don't know. Okay, let's put these over there so that we can still see them a little bit, somewhat, maybe. I don't know. Like that. Okay, I'm gonna I'm gonna fold this like so. There are 5 amp fuses in there. No, wait, okay. We might blow up the data port doing this, but we'll see. Oh wait, I know how to do it. Okay. We can actually open this terminal. This wire is too thick. Okay, we can use a thinner wire. This is stupid. Where is it? This one. Thanks, Iman. Appreciate it. So we're going to screw in this side. There. And then we're just going to... I want to... Okay, zoom out a little bit. Wait for the camera to stop wobbling. I'm just going to touch the other terminal. But since it's 48 volts, this is going to, you know, be pretty hefty. Okay, ready? Oh. Oh, we're drawing 10 amps. Okay. The fuse popped. And our status light is on, so that the fuse is blown for this port. So now, well, if there's something connected to that, you'd see the status light come on that this fuse is blown. And my power supply really had to work hard with delivering 10 amps, but then it did definitely blow that fuse. Yeah, so that works. And LEDs still work. Let's go to blends. The board did reset, but that's mostly because the power supply didn't have enough power to keep going, basically. No, these are actually fast blow fuses. Might not believe me, but they are. So let's see what I can set the amps to. Oh, I can only set it to 12.10 amps. Should we blow another fuse? Then we're calling it a day. Yeah, let's do it. Okay. 3, 2, 1. Oh. What? Oh, that's not going to work. I'm still in the positive of this terminal, so I need to move this to another terminal. Yeah, slow blow would take much longer. Okay, ready? Let's expose this a little bit more. 3, 2, 1. Bam! Oh, okay. The fuse had a violent end. What the hell? Okay, let's look at that fuse. Let me make a little bit more light. That fuse. So this was the first one. This was the second one. I think it actually split in half. Let me get it out. Let me get it. Okay, let me turn off power first before I get 10 amps on me. Oh, there was still some power there. Oops. Okay, I need a different tool. This fuse is gone. Okay, so this is the first one. That went pretty okay. And this is the second one. This one literally, well, kind of exploded somewhat, but not in a horrible fashion. We need a tiebreaker. Okay, sure. Could you still use this socket? I think so. It got a little bit warm, but I think a fuse would still fit in there. Let's try it. Yeah, that's fine. Okay. So let's blow this one. Now let's do a little bit of a different failure mode. Why does this wire not go in? Oh wait, no, I need a different wire. I want to do a different failure mode. I want to see what happens if you blow it up while booting, basically. No, this is too thick. No. No. Maybe? What's up with this terminal? Oh, it's not open. Okay. Red. And red. This is not how you're supposed to hook it up. Oh, sorry. Okay, so now we have our fusey loop-de-loop. And we're just going to hook that up to the board because we are stupid. And this is how we hooked it up. Later, Nigel. And I guess we might want a nice and close-up of the fuse. Still not focused there. One moment. Why are you not focusing? What are you doing, camera? Okay. Okay. So we have a nice and close-up of the fuse. And we're just going to turn on the power supply, see what happens. Right? 3, 2, 1. Oh, 12 amps. Oh, whoa. Okay. What the hell happened there? Did you guys see that? Let me do another one without the lights on, with all lights off. There. Okay, so now this one's blown. So let's turn off the power. Fuse LED, exact fire inside the fuse. Exactly. So now let's try it again with all the lights off. 3, 2, 1, go. Aw. This one went much quicker. Okay, I guess we're blowing more. We can blow the whole row. Okay, let's go. 3, 2, 1, go. Well, this one glowed a little bit. And of course, the once that fuse blows and everything is fine, the LEDs turn on, no problem. Oh, I'm not sure I can still focus. Oh, I can. No, wrong focus. Nope. Hold on, I need light to focus. There. Okay, let's do the last one. But I'm going to set my power supply to 8.5 amps. Right, so we're limited to 8.5 amps, but we have a dead short. 3, 2, 1, go. Yeah, limited to 8.5 amps. Maybe 8.5 amps isn't enough. Okay, 9.5 amps. Oh, there he goes. Oh, it's trying to live! No! Fire! Fire burn! These are 5 amp fuses. Oh, this one smells. Okay, so let's try one last, and then we're really gonna quit it. One last in this socket, which exploded the first time. Let's see if we can get it to focus somewhat. I don't know why the focus is so hard. Set. Focus. Let's give it a little bit of light. No, focus. There. Okay. We're set to 9.5 amps. Okay? 3, 2, 1, go.
They talk about another kind of word.
There's fire in it. It's still burning. What are you doing? What is going on? It's not extinguishing. Okay, there it goes. Okay. That was the best glowy and But, board works fine. Broken fuse indicator comes on. LEDs turn on. No problem. Everything works. No problem. Cool. So, although this might look spectacular, can you imagine what would happen if you did not have a fuse there? I mean, the amount of amps we're talking about aren't crazy, and power supplies people are hooking up are often 10, 20, 30, 60 amps. Yeah. Can you imagine what happens if this board would not have fuses? That would mean this wire, or the wire you have running to your LEDs or whatever, would become the fuse. Yeah. And I also really like the... I see a lot more boards with fuses out there now. That's good. I mean, but they all have rows of lights which show that the fuse is working. So then if a fuse blows, you'll have like 12 LEDs there, and then one of those LEDs turns off. And that indicates that the fuse is blown. But then you can't really see that because it's just a row of lights and maybe one of them is on or off. You don't want to stare into them because they're glaring. I designed it differently so that when the fuse blows, you get a red light instead of a green light when the fuse is working. I mean, I don't care if the fuse is working. I don't need to see that. I don't understand that design principle from those other boards. Why you would have a light if the fuse is working instead of a light when the fuse is blown. I want to know which fuse is blown. I don't care which is working. I mean, I assume they're all working. Do another sparky one as endgame. No, Philip. No. We blew up enough fuses for today. But, I mean, I'm happy to show that, still working. And we even still have the temperature sensor working. Exactly, Andy. But all the other boards out there that I have seen don't have a broken fuse indicator light. They have a fuse working light. And of course you need more circuit to make a broken fuse indicator light. But hey, I can do it with 48 volts even. So, I mean, all the power boards in Dig Octa have that. So, yeah. Is there going 6 amp through rest of components? How do you mean there, MC Mech? Let me unpower this and start cleaning up. No, I said last already 3 times. This is the last. This was the last. Yes. I think I've proven that it works. That was the official test. Trying if it works. It works. But I just, I just wonder about other boards or people running without fuses out there. Like, I don't know, man. I'm not sure I would do that. No, there's a whole circuit on every output port to make sure that it works like it does totality. Because the fuse also has an even brightness no matter the voltage. So on the normal power boards, those can take 5 to 24 volts, and on this board it can take 24 to 48 volts. The broken fuse indicator light is always the same brightness, no matter the incoming voltage. That's also an advantage of the circuit I use instead of doing it, the simple way. Because I don't like that my broken fuse indicator light is very dim at 5 volt and very bright at 24 volt because you tuned it for 12. That's also stupid. Or less than ideal. Yeah. Well, that's why we have the broken fuse indicators, right? I mean, the Dig Uno and Dig Quad don't have those because they're more space compact designs and stuff like that. But that's one of the advantages of the Dig Octa. It'll show you if you have a broken fuse, for sure. So I can control brightness of the glowing fuse through WLED. Is the rest of the components made for 6 amps, like without fuse? I'm confused what you're asking, MC Mech. This board, the power board, is specified to handle up to 30 amps total. So everything is designed to be able to carry that. So that's another thing the Dig Octa does that the Dig Quad and Dig Uno don't have. This board actually has input fuses and output fuses. So if something goes wrong with your cabling to the input of the board, those input fuses will catch that. So normally you'd have 2 or 3 lines running from your power supply, and maybe 2 fail and only 1 is left, but it's really thin, so then it gets way too warm. Then the input fuses cut that off and make sure it's safe, and then it has output fuses for all the output lines. Dig Uno and Dig Quad don't have that. We didn't test the input fuses. Let's test them. That's a bit more complicated there. But I've tested it all individually and I know it works, so don't worry about that. Yeah, so that's why this board isn't rated for 50 amps, but for 30 amps. That meant I could use PTCs on the input. And, I mean, with 30 amps, indeed, we're still talking around 1500 watts. At some point, it's enough, okay? Right? I mean, for 5 volt and maybe even 12 volt, I get you want like 50 amp support. Sure, power boards do that. We even have a 100 amp power board for 5 volt, or 12 or 24. But for 48 volt, I was like, okay, 30 amps, that's already a lot of power to play with. So let's cap it at 30 amps. Your kettle does more. Yeah, I know, but I think this is fine. Oh right. Let me. Okay. We're gonna. Hold on. I don't think I've ever shown off this box before, but I got it a while back. I don't even remember. His box is a bit mangled, and I don't even remember the voltage this is, but it's one of these strings. And oh, these are 24 volt. Okay, yeah. So these are 24 volt, but you can get these exact same type in 48 volt now, which will be single addressable. They're wired a bit differently because they have 4 wires instead of 3 wires. But I'm not sure this is the type of LED we're talking about. I had this as a test strip, but you now have 36 and 48 volt versions of this. So then you can run like hundreds of them with a single injection. No, these are like 1,000 lights, Philip. Because the spacing is only... I start to talk louder when I don't have my headphones on. The spacing for these is 5 centimeters. Well, I can't really show you. That's fine. The spacing is 5 centimeters. And this is like 50 meters or so. I don't remember. It was a long time ago. I used it for a few tests and then I didn't use it again. So... yeah. I just have the bare wires here. Data out. Oh, okay. Okay, well, whatever. Yeah, these are for sale on Aliexpress, including the 48 volt models, if you know, want to get a new power board. So let's put this back in its place. Okay, well that was a fun stream. We did lots of stuff. We tested some cheap ass Chinese crappy don't do what it says on the tin box or whatever power supplies, and they all didn't do. One came close. This guy is actually decent, or well, decent enough, I'd say. I mean, you can if you say 300 watts is 200 watts on this one, yeah. Construction looks good. There's an actual fuse in there. It did almost, 250 watts instead of 300. But if you treat it like a 200 watt supply, it'll get warm. It'll get hot. So maybe not use it in a box. But other than that, this one... And actually, this tiny one also surprised me. That it worked as well as it did. That it basically did 100 watts. That's amazing. Not sure I'd recommend any of these, but, So, yeah, that is going to be it for the stream today. Thank you all for watching and being here. That is always very much appreciated. We had some fun blowing up fuses and testing my new board. This will be available in a few weeks. The temperature sensors maybe might take a little bit longer. And yeah, I hope to see you guys back in the next video, on the next live stream, or maybe on the Discord server or in the video comments. Right? Thanks for watching, guys. Bye-bye.
There is something so wrong, and lately I don't know what to do. Picture perfect, but I'm dying, and I know you feel it too. When did we both get so still? Tell me something real. I need an adrenaline shot, make me feel what I forgot. Baby, grab the